This is a continuation of our previous video on plasmalogen. This video will focus exclusively on the synthesis of plasmalogen. Step number 1, in the first step, we begin with dihydroxy acetone phosphate. So the structure of dihydroxy acetone phosphate, this is dihydroxy acetone phosphate. To this, a fatty acyl-CoA is added. Fatty acyl-CoA is added. CoA is removed and the fatty acid is getting attached to carbon number 1. So if it is getting attached to carbon number 1, CH2O or Cr1, this is the product we are getting. This is nothing but 1 acyl dihydroxy acetone phosphate. Now this is catalyzed by an enzyme, that is a transferase enzyme. So an acyl transferase catalyzes this reaction. This is step number 1. What happens in step number 2? We will convert here and then we will continue explaining this step. In step number 2, this fatty acid is being replaced with a saturated fatty alcohol. So therefore, in step number 2, a saturated fatty alcohol is being added and it will displace this fatty acid. So therefore, COOH is removed and that gets incorporated at carbon number 1. So therefore, we have CH2O . So this is the molecule. Fatty alcohol is being added there. Now the name of the product is, now it is going to be 1-alkyl dihydroxy acetone phosphate. Now the name of the enzyme is 1-alkyl dihydroxy acetone phosphate synthase, or it is also known as alkyglycerone phosphate synthase. Alkyglycerone phosphate synthase. So therefore, at the end of step number 2, we have this product. Now in step number 3, what is going to happen is there is a reduction occurs to this keto group. In step number 3, an NADPH reaction, NADPH plus H plus, 2 hydrogens are added across this. So therefore, we are going to get CH2O, CH2, CH2R. This is CHOH. Reduction has occurred at carbon number 2. The name of this product is now this is a glycerol. 1-alkyl glycerol 3-phosphate. 1-alkyl glycerol 3-phosphate. Now this is catalyzed by 1-alkyl glycerol 3-phosphate oxidoreductase. So therefore, at the end of step number 3, we have this product. Now in step number 4 is to attach a fatty acid to carbon number 2. So therefore, we have a fatty acyl-CoA. CoA is removed, catalyzed by a transferase enzyme. Fatty acid will be attached to carbon number 2. So therefore, the product is this. A fatty acid is attached here. So this product is called 1-alkyl 2-acyl 1-alkyl 2-acyl glycerol 3-phosphate. So this is what we get at the end of step number 4. Now in step number 5, what happens is to remove this phosphate group. Why we need to remove the phosphate group? Then only ethanolamine can be added to this. So step number 5, which is catalyzed by a phosphohydrolase, a molecule of water, inorganic phosphate is removed. So what happens in step number 6? A CDP ethanolamine is added to this, a CMP is removed, and ethanolamine will get attached at the third position. So therefore you are going to get this molecule is 1 alkyl 2 acyl glycerol ethanolamine. Now this is catalyzed by an ethanolamine transferase enzyme. The name of the product is 1 alkyl 2 acyl glycerol 3-phospho-ethanolamine. Remember that this particular phosphate group is coming from the CDP ethanolamine. So therefore we have 1 alkyl 2 acyl glycerol 3-phospho-ethanolamine. Now we get to the last step. What happens in step number 7? A double bond is introduced into this alkyl group, and that double bond is introduced by a cytochrome B5 desaturase enzyme, and as we know, this will remove 2 hydrogens and it requires an O2, therefore it will be converted to 2H2O. So in addition to this, we also requires NADH plus H plus, so that compensate for the 4 hydrogens that are there in the 2 molecules of water. So what happens to the structure? The structure will be now CH2O, CH, a double bond is created. This is the structure of plasmalogen. Now instead of ethanolamine, it can be choline. You can have a choline plasmalogen. This is an ethanolamine plasmalogen. Depending on the need of the cell, such molecules will be produced. What we have seen in this particular video is the kind of research that was carried out in its identification of this molecule. Then we looked at all the 7 steps that leads to the formation of plasmalogen. So we should also understand if the first 2 steps will take place in the peroxisomes, and if the last 5 steps will be taking place in the endoplasmic reticulum.